second video for 3-4, dividing polynomials, and this picks up with example 3. We want to know how is the value of p of a related to the remainder of p of x divided by x minus a. So we have this example here. Our p of x equation is x cubed plus 10x squared plus 29x plus 24, and we are dividing by x plus 5. So because the formula here has that x minus a, remember to find the actual a value, you do need to solve that equation. So your a value is actually going to be a -5, and I'm going to use synthetic division on this because that's going to be a lot easier than going through the long division process. So I have my -5 here. So my coefficients in my polynomial, I'm not missing anything from the x cubed down to the constant term. So I have a 1, a 10, a 29, and a 24. So I bring down the first term, multiply by the -5, put in the next box, add together, multiply by the -5, put in the next spot, add down, multiply by the -5, put in the next spot and add down. So it says, how is the value of p of a, so I'm going to have to plug a into my function, and the remainder, how are they related? So my remainder there is 4. Well, if I take a look at p of -5, that's -5 cubed plus 10 times -5, or -5 squared and then times 10, plus 29 times -5 plus 24. And when you do that math and simplify, you end up getting 4. So the value of p of -5 is equal to 4. That is the same thing that you get from the remainder. So the relationship, how is p of a related to the remainder? They are the same. Which means instead of plugging in values into functions, you can actually do synthetic division, and whatever you get for the remainder using synthetic division, that's always going to be your value. So in many cases, synthetic division ends up being a shortcut instead of going through that whole process, especially if you don't have a calculator. The math is a little bit easier. So the remainder theorem. If you have a polynomial that's divided by x minus a, the remainder is always going to be p of a. So it's whatever you get when you plug a into the original polynomial. And then we have the factor theorem. So we're going to use both of these in the next couple of examples. The factor theorem says the expression x minus a is a factor of your polynomial p of x if IFF stands for if and only if. That means it is a biconditional statement. Both the statement and the converse are true. So if IFF, p of a is equal to 0, which means x minus a is a factor if p of a is equal to 0, and if x minus a is a factor, then p of a is equal to 0. So both of those statements are true. Either you plug in and you get a 0, then it's a factor, and if you know it's a factor, you can plug in and get 0. So first we're going to look at the remainder theorem. This is word problem. It says population of tortoises on an island is modeled by this function, where x is the number of years since 2015. Use the remainder theorem to estimate the population in 2023. Well, in 2023, because it's years since 2015, that means your a value is going to be 8, because 2023 is 8 years since 2015. So I'm going to set this up with synthetic division. Even when you're using the remainder theorem, you still have to put in zeros if you are missing any terms in sequence. This one is not missing any. So I have -1, 6, 12, 325. Bring down the -1, multiply by the 8, add down. Multiply by the 8, add down. Multiply by the 8, and add down, and we end up with 293 tortoises. So there's 293 tortoises estimated in 2023 using the population equation that they gave. Now we're looking at the factor theorem. Well, and the remainder theorem, I guess, as well. So it says, how can you use the remainder theorem and factor theorems to determine whether the given binomial is a factor of p of x? If it is a factor, write the polynomial in factored form. So we are going to set up synthetic division. If the remainder is 0, then I know it has to be a factor. So with this binomial, my a value would be 6, because again, I have to set it equal and solve. I'm going to put all my coefficients across the top. I'm not missing anything in sequence, so I didn't have to put any zeros in. And then I go through and do my process. Bring down the first, multiply by the box number, add down, multiply by the box number, add down, multiply by the box number, add down, multiply by the box number, and add down. So yes, this is in fact, x minus 6 is a factor of this polynomial. The factored form then is going to be your original divisor, so the x minus 6, times the depressed polynomial. So that's the polynomial that is left over when you do synthetic division. So again, remember, we take the highest exponent and we knock it down by 1, so it's now going to be x cubed. That's what the 1 goes with. The minus 2 then goes with the x squared. The 4 goes with the x. This 1 is the constant term, and then there's no remainder, so I'm not going to put the remainder on the end. So that is the factored form. So if they ask you for factored form, that's what you would have to write. And now we have this one, same kind of setup. My a value for this one is going to be -3. I'm going to put my coefficients, so I have my 1. Notice I'm missing an x to the 4th, so I have to put a 0 in there. Then I have my -5, my 9, my -1, and my 3. So bring down the 1, multiply by the box number, add down, multiply by the box number, add down, multiply and add, multiply and add. And whenever I do this one is not a factor. Maybe I can write that so you can actually read what's there. This is not a factor because the remainder is not 0. Not a factor because your remainder is not 0. You only have a factor if your remainder is 0. So on your textbook on page 159, there's a concept summary that goes through long division, synthetic division, and then if you look at the rest of this, there's the remainder theorem and there's the factor theorem. So this is all available if you need just one page to review everything that we went over in section 3-4. And again, that is on page 159 in your textbook. So go back. If you have any questions on this, you can go back, rewatch this video, rewatch the first video. There are other videos out there online that go through polynomial long division and synthetic division. So please seek out those resources as well if you need extra help. And as always, contact me if you have any questions.